Picture a planet somewhere far out in the dark, and picture someone standing on it, tipping their head back to look at the sky, the way you might step into your yard tonight and look up. Except their sky is almost completely black. No glowing band arching overhead, no scatter of bright neighbors, just their own handful of stars, and then nothing. If the people on that world ever built telescopes and aimed them outward, they could spend centuries convinced their galaxy was the whole of creation because the nearest other galaxy would be too far and too faint for them to ever find. That world is not a fantasy. There is a region of space where this is the actual view, a place so enormous and so empty that living inside it would change what an entire civilization could even believe about the universe. We've found it. We've traced its edges and counted the little that survives inside it. And by every rule we've written about how the cosmos puts itself together, a whole this big and this barren has no right to exist. It's called the Boötes Void, and today we're going to work out how the universe ended up with a hole in it. Here's the key to understanding a void. The hard part isn't the size, it's the emptiness. And to really feel that, you first have to unlearn what the word empty even means. Down here on Earth, empty is a soft, harmless thing. An empty room is still packed with air you can breathe. A silent forest is still teeming with insects and roots and life. Our whole world is aggressively, generously full. Wherever you point your eyes, something is there. Space does not play by those rules. And to understand why the Boötes Void is so unsettling, we need to leave our crowded little world behind and get a real sense of how thinly the universe is actually spread out. We won't do it by asking how long it would take to fly out there, because that road goes nowhere useful. We'll do it by paying attention to something quieter and stranger instead. The age of the light. Every time you look at something in the sky, you are not seeing it as it is. You're seeing the light that left it. Which means you're always looking slightly into the past. And the farther away the thing is, the deeper into the past you're staring. Take our own sun. Its light takes about 8 minutes to reach us, so that golden sunset you watched last week didn't happen when you saw it. It happened 8 minutes earlier, and you only caught the memory of it as the light finally arrived. You have never once seen the sun as it truly is in the present moment. Nobody has. Now go further. The closest star beyond our sun is just over 4 light-years away, which means the pinprick of light from it sliding into your eye tonight actually set out about 4 years ago. You're seeing a star as it looked 4 years in the past. Push all the way across our own galaxy, the Milky Way, and the numbers turn vertical. Light needs around 100,000 years to cross it. So some of the stars near the far edge are showing you light that departed when our earliest ancestors were just beginning to spread across the face of the Earth. You're not looking at those stars. You're looking at deep prehistory. And our nearest large galactic neighbor, Andromeda, is about 2.5 million light-years away. The faint smudge of it you can spot on a dark night is light that began its journey before our species even existed. We are, quite literally, the first humans ever to see it. Sit with that for a second. The deeper we look into space, the further back in time we travel, and the more thinly everything is spread. Now let's use that emptiness to build something you can actually picture. Let's shrink the entire Milky Way, all 100,000 light-years of it, with its few 100 billion stars, down to the size of a single dinner plate sitting on your kitchen table, about 30 centimeters across. On that scale, where would Andromeda be? Not on the table, not in the kitchen. Andromeda would be a second dinner plate floating roughly 7 or 8 meters away across the length of a large room. That's the gap between our galaxy and the next big one. 2 dinner plates, a room apart, with almost perfect emptiness in between. And if you could rise up high enough to see the whole universe at once, you'd find those plates aren't scattered at random. They string together into a vast glowing pattern. Picture flying over a darkened country at night and looking down. You'd see bright knots where cities cluster together, and those clusters strung along glowing highways, with huge stretches of pitch-black countryside in between. That's what the universe looks like at the largest scale. Galaxies gather into bright clusters. The clusters are linked by long bridges of galaxies, and between all of it lie enormous dark stretches where almost nothing lives. Astronomers call those dark stretches Voids. They are the empty countryside of the cosmos, and most of them are big, but ordinary. Just part of the pattern. The Boötes Void is not ordinary. In 1981, an astronomer named Robert Kirshner was carefully measuring the distances to galaxies in one slice of sky, toward the constellation Boötes, building a three-dimensional chart of where everything sat. And in that chart they hit a gap. The galaxies simply ran out, across an enormous span of distance, in field after field. Something vast and hollow was sitting out there in the dark. When they finally pinned down its size, the number was hard to accept. The Boötes Void measures somewhere between 250 and 330 million light-years across. Let me put that back on our kitchen table scale. Remember, the whole Milky Way is a single dinner plate. On that same scale, the Boötes Void would be an empty sphere nearly a kilometer wide. A bubble of near total nothing, almost a kilometer across, in a universe where the plates are normally only a few meters apart. It is so large that it accounts for close to 2% of the entire observable universe. One single empty bubble, and it makes up 1/50th of everything we can see. And it begins only about 700 million light-years from us, which on cosmic terms is practically next door. Now, the word void oversells it a little, and I want to be straight with you about that. It isn't a perfect vacuum, and it isn't completely starved of galaxies, but that's exactly where the real shock lives. Based on how galaxies are spread everywhere else, a region this size should be home to somewhere around 2,000 galaxies. When astronomers first searched inside the Boötes Void, they found a single one lonely spiral, adrift with no neighbors for tens of millions of light-years in any direction. Years of patient searching with better instruments slowly raised the count, but only to around 60 in a space built to hold thousands, and most of them huddled out near the edges, leaving the center almost perfectly hollow. The thinnest regions inside it are among the emptiest places ever measured anywhere in the observable universe. The astronomer Greg Aldering once captured the scale of it with a thought that still stops me cold. If our Milky Way had happened to form deep inside this void, instead of where it actually sits, we wouldn't have realized other galaxies even existed until somewhere around the 1960s. Think about what that means. For nearly all of human history, we would have looked up, built our instruments, aimed them at the heavens, and seen only our own stars, and then an endless wall of black. We'd have been certain our galaxy was the entire universe. That is how empty this place is. Empty enough to have hidden the rest of creation from anyone unlucky enough to live at its heart. So how do you make a hole like this? This is where it stops being a ghost story and turns into real science, and the answer is genuinely lovely. Rewind to the infant universe, not long after the Big Bang. Back then, matter was spread out almost perfectly evenly, like a faint mist filling all of space. Almost perfectly, but not quite. There were tiny imperfections. Some patches were a hair denser than average, and some were a hair thinner. And gravity is patient. Gravity never lets go. Over billions of years, the patches that started slightly denser pulled in more and more material, swelling into the bright clusters and glowing bridges of the cosmic web. But all that material had to come from somewhere. It was drawn out of the thinner patches nearby. And as those thin patches surrendered their matter to their greedier neighbors, they grew emptier, and emptier, and emptier still. A void isn't a place where something was destroyed. It's a place where, across the entire lifetime of the universe, gravity quietly drained everything away, the way water slowly retreats from high ground until only dry land is left. The galaxies were never erased from the Boötes Void. They were gently, relentlessly pulled toward the rim over billions of years, leaving behind the great hollow we see today. And the handful of stragglers still inside it seem to line up along a strand through the middle, which hints that the Boötes Void may actually be several smaller voids that merged over time, the way two soap bubbles join into one larger bubble. So the whole makes sense after all. It isn't a flaw in the cosmos. It's gravity doing precisely what gravity always does, just on a scale we can barely hold in our minds. Which would be a perfectly satisfying place to stop. But the universe has one more move to make, and this one is stranger than the void itself. Because here's an uncomfortable question. This whole time, we've talked about the Boötes Void as something out there, far away, a curiosity we study from a safe distance. What if we're sitting inside one? In 2013, 3 astronomers were counting galaxies across most of the sky, measuring how densely they're packed at different distances from us, and they ran into something they didn't expect. Our own local stretch of the universe, the region our Milky Way lives in, seems to hold noticeably fewer galaxies than the regions farther out. We appear to be sitting near the middle of a large, underpopulated bubble. They called it the KBC Void, and it is gigantic, roughly 2 billion light-years across, which would make it many times wider than the Boötes Void, possibly the largest such region anyone has identified. It isn't nearly as barren as Boötes, only around 20% below the normal density. But it's big enough and close enough to swallow everything we know. Our galaxy, our sun, this planet, you right now. We might be living inside a hole in the universe. And this is not just an eerie thought, because it might crack open one of the biggest unsolved problems in all of physics. For years, scientists have been stuck on something called the Hubble tension. When they measure how fast the universe is expanding by watching nearby galaxies, they get one answer. When they measure it using the faint afterglow of the Big Bang, they get a different answer. The two stubbornly refuse to line up, and no one has fully explained the gap. But picture what living in a void would do to that measurement. If our entire neighborhood is thinned out, then all the denser regions surrounding our bubble would be gently tugging on everything near us, pulling galaxies outward toward the crowded rim. From the inside, that outward tug would make our local patch of the universe look like it's flying apart faster than the true average. Our nearby measurement would come out too high, and the tension would quietly dissolve. Evidence for this underdense bubble keeps turning up across the spectrum in optical, infrared, X-ray, and radio observations. As recently as 2025, fresh analyses of the ancient sound waves frozen into the early universe were being used to argue that, yes, we really might be cradled inside this billion light-year hollow. But I want to be careful and fair here, because this is genuine science, not a tidy story. The KBC void is still debated. Plenty of cosmologists find it a difficult idea to accept, and some studies argue the bubble simply isn't deep enough to explain the Hubble tension on its own. It's a leading possibility, not a settled fact. The next decade of measurements will either harden it into something real or rule it out for good. Still, let the possibility sit with you for a moment. We began this journey imagining the Boötes Void as a distant, frightening emptiness, a hole punched in some far-off corner of the cosmos, and we may be ending it with the realization that our own home, our galaxy, our entire local universe, could be quietly floating near the center of a hole of its own. One so faint we never noticed it, and yet so significant it may have been bending our view of everything all along. That's the strange gift the universe keeps giving us. The more carefully we map it, the emptier and more humbling it turns out to be. We are not the bustling center of a crowded, glittering cosmos. We may be a small island of light, clinging to one ordinary thread of the great web, possibly adrift inside one of its vast hollows, gazing out across oceans of nothing. And the most staggering part of all of this isn't the emptiness. It's that a species of curious creatures standing on a single small rock managed to look out into that darkness, measure the precise shape of the nothing, and begin to understand it. If this is the kind of thing that keeps you happily awake at night, think about subscribing. We go chasing mysteries like this all the time. And tell me down in the comments, which corner of the cosmos should we go explore next?